Hello students, so my name is Madam Cha. Today I will discuss the question 7 hydroxyl compound. This is the analysis PSPN question start from the 2018-19 to 2020-21. So we found that 2018-19 is more focused to preparation of alcohol and the synthesis about alcohol. 2019-20 is talking about the reaction of alcohol and oxidation about alcohol. And then the last year 2020-21 is talking about oxidation alcohol. Before we discuss the question 7, so let us match the observation of Lucas test and oxidation by using the potential permanganate solution with class of the alcohol. So the first picture is a Lucas test, which is from cloudy solution. The second picture, this picture is a show of the potential permanganate is a remain unchanged. So what is the class of this observation? Alright, okay, come. So the answer is yes, tertiary alcohol. So now for second picture, you can find that the cloudy solution form and then they're able to be oxidized. So meaning that this is a secondary alcohol. So where is a tertiary alcohol, the cloudy solution form immediately. Secondary alcohol, the cloudy solution form maybe after 5 to 10 minutes. So the last one, the last picture, you can find that no cloudy solution form for Lucas, but they can be oxidized, meaning that this is a, yes, answer is a primary alcohol. 7a, A and B have same molecular formula C4H10O. Usually, right, so we found if a 1O, usually the answer maybe is alcohol, maybe is ether, or maybe is a carbonyl. So from the how many number of carbon and hydrogen, we can predict this is a possible is alcohol. So reaction of A and B with potential dichromate solution and Lucas reagent are as follows. So this is isomer A, which should give a positive result with the potential dichromate solution, meaning that the structure A can be oxidized. And Lucas reagent is a negative result, meaning that this is a primary alcohol. For structure B, negative result for potential dichromate solution, it means they cannot be oxidized, but they give you positive result for Lucas. So cannot be oxidized, meaning that this is a tertiary alcohol. So from the observation, we can predict the class of alcohol. Okay, now we look at the question 1. Suggest a structural formula for isomer A and B. So this is the structure question 1. Question 2, predict the structure of alkene formed when isomer B undergo reaction with concentrated sulfuric acid. Okay, now we look at the answer for structure A and B. So just now we already predict the answer for A is a primary alcohol. So you recall our memory again. How to draw primary is a first one. We'll look at the carbon. This is alpha carbon bond with OH, and then the alpha carbon will bond with 1C, and then 2H. So this is called primary alcohol. So because the structure contains 4 carbon, so I already confirmed 2 carbon. That means the balance is a 2 carbon more. So of course the question you can draw in the branch like this. So this is the answer for branch, still primary alcohol. So now for structure B is a tertiary alcohol. How am I going to draw tertiary alcohol? Student can draw the COH first. This is the alpha carbon, and the carbon must bonded to 3 carbon. So this is called tertiary. So now student can count how many carbon you use. Total is 4. It means already fulfill the structure. So after that, we complete the hydrogen to complete the formula of the structure. 7b, predict the structure of alkene formed when isomer B undergo reaction with concentrated sulfuric acid. So as you know, alcohol with concentrated sulfuric acid is the answer is alkene. So how are we going to get the answer is we can draw the structure, expand all the carbon and the hydrogen first. Okay, after that we can label this is the alpha. To this is a process dehydration where we'll remove the H2O. For alpha carbon, we'll remove the OH. And then beta carbon will remove the H. So now, how many beta carbon we have? So first one, beta 1, beta 2, and beta 3. So student, you can find that beta 1, CH3, beta 2, CH3, beta 3 also CH3, meaning that you remove the H at beta 1, beta 2, beta 3, you will give the same product. It's the same thing, yeah, same thing, right? So that's why you can choose beta 1 or beta 2 or beta 3 to remove the H. So I will remove the H, then this part will become the C double bond C. So that's why the answer becomes C double bond C at the beta 1 and alpha. So if a student remove the beta 2, right, actually the answer is the same. So you get the double bond on the right side and this is a branch. It's the same thing. So if you remove the beta 3H, so you get the answer is a double bond at here. So actually it's the same thing. Yeah. So that's why for this case, you can check your beta 1, 2, 3. If the same thing, you just show me one answer enough. If a difference, you need to show more answer. So far the answer is a one product only. That is a alkene. Now we discuss the question C, which is arrange the following compound on increasing order of boiling point. Expand your answer. So when you're talking about boiling point, you must talking about the intermolecular force they form. So now we try to differentiate what is the difference between these three structure is this one is contain the OH. So this is a OH. This one the structure contain 2 OH. So as you know, OH can form hydrogen bond. So what is a hydrogen bond? Hydrogen bond is the first criteria is you must found the H, and then the H must be bonded to the F or O or N. So that means this H is qualified to form hydrogen bond. Qualified only. So how they form hydrogen bond is the H must meet with another F or O or N. So they form the intermolecular force. Then this is called hydrogen bond. So this is a criteria. So that means alcohol, right, contain this is alcohol. So this is a H bonded to O. So that means this H is qualified to form hydrogen bond with another alcohol, which is a contain F, O, or N. So this is called hydrogen bond. Alright. So that means if the structure contain OH, so they can form the hydrogen bond. So this one can form hydrogen bond. So structure number 2 also able to form hydrogen bond. But the structure number 3 contain 2 OH, meaning that they can form more hydrogen bond. So now after we discuss these three answers, right? So automatically we know this is a highest boiling point. Yeah, because they can form more hydrogen bond, right? Okay now. So now between the pentanol, one pentanol and one propanol, so which one is the lowest boiling point? Okay, now the factor is difference between them is a number of carbon. So this is a 5 carbon and the second structure is a 3 carbon. So as you know, the carbon hydrocarbon is form the van der Waals force. So this is a 5 carbon, right? So they provide the larger surface area, larger molar mass. You will form larger van der Waals force. But for 3 carbon, right? So the provide their smaller molar mass. They will provide the smaller surface area, so weaker intermolecular force. So from these two answers, student you can predict which one is give the lowest boiling point, which one is less energy needed to breaking intermolecular force. Yes, the answer is the structure, the 1 propanol. So this is the lowest boiling point, Right. So the second one is the 1-pentanol because larger molar mass, they give you stronger van der Waals force. So which one is the highest? Yes, this one is the number third one, highest boiling point because they provide more OH and can form more hydrogen bond between molecules. After we discuss the criteria of the structure to arrange the boiling point, so now we can answer the question by write the increasing boiling point, and this is a 1-propanol with a comma, and then the 1-pentanol comma, and then 2,3-pentane-diol. So I more encourage you all using the comma to arrange the increasing or decreasing, right? So more easy to understand and avoid the mistake happen. So now after that we can compare 1-propanol has a lower boiling point than the 1-pentanol because lower molecular weight they will give you the weaker van der Waals force. So which is both can form the hydrogen bond. So now how about 2,3-pentane-diol compared to the 1-pentanol? So 1-pentanol has a lower boiling point than the 2,3-pentane-diol because they have a 1O hydroxyl group, and then for the 2,3-pentane-diol contain the 2 hydroxyl group. So meaning that 2,3-pentane-diol can form more hydrogen bond compared to the 1-pentanol. So hopefully you enjoyed the discussion today. So this is Madam Chia from question 7.